All right, 5.5, we're going to be solving systems of equations algebraically. We're going to use and build right off of what you did last year in grade 10, is you did systems of equations, but you did a linear system. Now we're going to look at linear quadratics and quadratic systems and apply the same concepts that you've learned already. So let's go back and look at what you did previously in linear systems. Two different methods that you learned. You learned to either use substitution or to use elimination. So let's look at the first one, and we'll solve it by substitution. Substitution is always easiest when you can isolate one of the variables. And this one already has y isolated, so all we're going to do is we're going to take that y, which equals 4x minus 4, and substitute it in for the other y. So 2x plus 3 times 4x minus 4 is equal to negative 5. Distribute that in. 2x plus 12x minus 12 is equal to negative 5. So we get 14x minus 12 equals negative 5. And then add the 12 over. 14x is equal to 7. Divide by the 14. X is equal to 1/2. Now that we have what the x is equal to, we're going to plug it back into either one of the first two equations. Equation number 1 looks like it's going to be easier because we already have y isolated. So then y is equal to 4x minus 4. Substitute that in for the x. So y equals 4 times 1/2 minus 4. Y is equal to half of 4, that's 2. 2 minus 4, y is equal to negative 2. The last thing that we always want to do is put your answer as a coordinate pair, because it is the intersection between those two lines. So we'll put it as an intersection point. Let's go to the second system. In this one, I'm going to show you again your elimination method. So we can't easily isolate an x or y, so let's use an elimination method. I need to get the coefficients on either the x or the coefficients on the y to be the same. So, well, let's multiply the first one by 2, which will make us 6x, and we'll multiply the second one by 3, which will make us 6x as well. So multiply this one by a 2. We'll multiply this one by a 3 to get a lowest common multiple. Equation number 1 is going to turn into 6x plus 4y equals 18. Label it as 3. It's a new equation. Second system, multiply it by 3. We also get 6x plus 9y is equal to 33. Let's call that equation 4. You could have taken this as a negative so that you could add, and that would be easy as well. We're now going to subtract these two. So if you would have taken a negative, we could have added the two equations. Now we're going to subtract 4 from 3. So we subtract equation 4 from equation 3. 6x minus 6x, those are gone. 4y minus 9y, that's going to give me negative 5y. 18 minus 33, negative 15. Divide by negative 5, y is equal to 3. Take a y of 3 and plug it back into either 1, 2, 3, or 4. You got 4 options to put it into. So I'm just going to use the first one, just because it's there. So 3x plus 2y equals 9. 3x plus 2 times 3 equals 9. 3x plus 6 equals 9. So 3x is equal to 3. I'm going to subtract over the 6, divide by the 3, x is equal to 1. And again, put your answer as a coordinate point. X, comma, y. For this next question, I highly recommend that you pause the video, that you try it yourself. Again, you learn a lot more when you try these parts out yourself, and then check and see if you got it right. Use the same process that we just did. When you have a quadratic one, though, it's better to use, it's better to use your substitution method. So we're going to substitute the linear into your quadratic. So both of them are equated to y, so all we're going to do is we're going to take the y and substitute it in here. So x plus 2 is equal to x squared. We've got a quadratic. The same as we've got quadratics all the way along, equate to 0 and factor. So 0 equals x squared minus x minus 2. Let's factor that. I'm going to just put the equals 0 on the other end there. X minus 2 and x plus 1 equal to 0. So x is either equal to 2 or x is equal to negative 1. There's our two answers. So we've got two answers, two intersection points that we're going to have to work with. So if x equals 2, then substitute it back into either one of the first equations, equation 1 or equation 2. Doesn't matter. Whichever one you find easier to work with. I'm just going to work with the linear. Y equals 2 plus 2, which equals 4. So your point of intersection on this one is 2, 4. Now if x was equal to negative 1, then we plug in negative 1. Y equals negative 1 plus 2. And y is equal to 1. So our point there of intersection is equal to negative 1, 1. So if we look back at all the different types of solutions that we have, if we're looking at a linear system, that's a linear and linear, two lines, your options that you had was one line, another line, intersecting to give one solution. We could have also had one line and the second line being parallel and giving you 0 solutions or no solutions. We could have also had one line and a coincident line, which is a line just kind of offset but right on top of it, having an infinite number. So let's look at the same type that we can have for linear and quadratics here. So a solution of a linear quadratic system of equations is an ordered pair, x, y, that satisfies both equations in the system. This system may have 0, here in that first one, or it may have 1. This is tangent. So one point of intersection is called tangent. Or we may have 2 solutions. Those are the only options that we can have. All right, so solve this system. We've got a quadratic and we've got a linear. Well, isolate one of the variables. Oh, the y is already isolated on this one. So I'm just going to substitute the quadratic into the linear this time. Whichever one has the variable isolated is easier to work with. So then we get x plus 1/3 x squared minus 3 equals negative 3. Let's collect our like terms. And we get So taking the -3 over to the other side, we're going to get 1/3 x squared plus x. Actually, I'll bring this -3 over here, equals 0, either way. I don't really like having this fraction. I'm gonna get rid of the fraction by multiplying the whole thing by 3. Both sides of the equations, if you multiply every term, then it's still going to be the same. So that's going to be x squared distributed in plus 3x still equals 0. This is going to be a little bit easier to work with. Hey, let's factor out an x here, a GCF. X, so we have x plus 3 equals 0. So my two answers here now, I've got two solutions. Either x is equal to 0 or x plus 3 equals 0, so x equals -3. Work with each one of those. If x equals 0, plug it back into either one of the two, either the quadratic or the linear, whichever one you want. I'm going to plug it back into the linear. 0 plus y equals -3, so y equals -3. There's my coordinate point, 0, -3. But if x was equal to the -3 point, then I plug that one in, -3 plus y equals -3. Add the 3 over, y equals 0. So my coordinate point now is going to be -3, 0. And there's my two intersections. So now, question is, in that last example, could we have used elimination? Well, one of them had an x squared, one of them had an x. I can't add or subtract to be able to eliminate one of those. However, both of them had a y. So I could have eliminated the y's. So can't eliminate the x, because 1 is squared, but we could eliminate the y. What that's going to do is it's going to give you a quadratic with an x squared and an x left in it, and then you would factor just the same. Okay, the next part there on page 393 shows you how you can verify using your calculator. And that would just be plugging in the two different equations. You have to have y equals and y equals to make this work. And then just finding your intersection point, the same way that we found intersection points from 5.4. So quadratic system now, again, we're looking for the intersection point or points. With these ones, we can also have no solution if they don't cross each other. If they just touch in one place, tangent to each other, we would have one solution there. We could also have two solutions. Or if we have two equations that actually turn out to be the same, one right on top of the other. Again, just like the linear system, we could also have an infinitely many solutions. So example number 2. Let's solve this system. Again, we have y isolated and y isolated, so let's just substitute one into the other y, which now gives us x plus 2 squared minus 1 is equal to x squared minus 4x minus 5. So we always need to have a variable isolated in order to do this. We can't have it isolated and maybe equal to 5, and this one would be equal to 5. We can't use that. It has to be isolated for a variable in order to use this method. Going further, let's expand the quadratic. We've got a quadratic, so we're going to need to collect our like terms and equate to 0 and factors, same as always. So let's expand this side. X squared. Make sure it's not x squared plus 4. You got to expand this x plus 2 times x plus 2. So x squared plus 4x plus 4 and minus 1. Collect our like terms and equate to 0. So let's bring all this over to this side. Oh, nice thing that when we subtract the x squared, we subtract the 4x, and when we subtract, add the 4x, and add the 5, this was equal to 3 here. We get left with, those ones canceled off, we get 8x plus 8 equal to 0. And let's just solve for the x now. 8x is equal to negative 8, divide by the 8, x is equal to negative 1. We only got left with a linear here. The x squareds canceled off, gave us one solution. There's only one intersection point. There's one solution only. So take our negative 1, plug it into either one of these. Doesn't matter which one you use. I'm just going to use the first one. Y is equal to negative 1 plus 2 squared minus 1. Y is equal to 1 squared, which is 1. So y is equal to 0. And my intersection point, and there's only one of them here, negative 1 comma 0. Again, if you wanted to, you could verify this on your calculator. All right, example number 3. Two numbers are related in this way. Square the first number, subtract the second number is equal to 5. And the first number is equal to the second number, subtract 7. Ooh. Let's create this system. Make two different equations. Square of the first number, we'll just call the first number x. So let's let x equal first number. If ever you're using variables, they don't give them to you, you need to define them. So x is the first number, so then y is equal to the second number. X squared, subtract the second number, is equal to, so equal sign, equal to 5. There's equation number 1. Equation number 2, first number is equal to second number, subtract 7. There's equation 2. And you look at what type of system do we have? We've got a linear quadratic system. Well, let's put one into the other. Hey, we've already got x isolated, so let's just plug that in for the x there. So then y minus 7 squared minus y equals 5. So an alternate strategy that we could do as well, we could do this one, or if we wanted to, we could isolate the y and the y, and then make them equal that way. Whichever one looks easier. So this one, you would have to expand to make a quadratic. You would be solving for y at that time. Let's see what happens if I take the y over to this side and bring the 5 over to that side. And I get y equals x squared minus 5. That's from the first equation. Still the first equation. And then if I isolate this one, take the 7 to that side, y equals x plus 7, and that one. And then at this point, I could just substitute that into there. So either way is going to work. The first one, you're going to solve for the y first. The second one, you're going to solve for the x first. Whichever one you find easier, work with it. Really doesn't matter which way you go. I'm just going to go with this way so that I don't have to expand the quadratic part. So then x squared minus 5 is equal to x plus 7. I got a quadratic, equate to 0, and factor. X squared minus x minus 12 is equal to 0. Factor that, that's going to be x minus 4, x plus 3 equal to 0. So my two answers, two intersection points here now, x equals 4 or x equals negative 3. So if x equals 4, when x is equal to 4, we're going to plug that back in and solve. We can use either equations. We've got four options. We can use this one, we can use that one, we can use this one, we can use this one. I'm going to use the easiest, y equals x plus 7. So y is equal to 4 plus 7. Y is equal to 11. Our intersection point then is 4, 11. Do the same thing with the negative 3. Y equals negative 3 plus 7. Y is equal to 4. So our second intersection point, negative 3, 4. So then what do these points of intersection actually mean? What it means is the numbers are either 4 and 11. So the numbers are either 4 and 11, or they're negative 3 and 4. Those are the two options that we could have, and it would still meet the criteria that the question gave right at the very beginning. Work through your discuss the ideas questions there, the two of them on page 396. It's also good to note that little paragraph there in the middle that's just saying, hey, if it's not factorable, use your quadratic formula. Don't forget about that. That's a method of solving. And you've also got your graphing methods to find the intersection points to help you through as well. All right, so do those discuss the ideas questions.